Point 2, troubleshooting parallel circuits. Parallel circuits are a basic way of connecting components, but may be difficult to troubleshoot. Logical, professional methods need to be used when troubleshooting complex circuits. 3 rules that also apply to troubleshooting parallel circuits are, and we introduce this in section 5.1 on series circuits, make a measurement only if you know what a good reading should be. Make as few measurements as possible and select the best tool for the task at hand. This is one of the tools that can be used with parallel circuits, a current probe. A current probe senses the magnetic field produced by a current-carrying conductor and produces a corresponding voltage. Current probes are useful for circuits with discrete interconnecting wires. Some will only work with AC and must be clamped on to the circuit. Others will work with DC as well. So troubleshooting with a current probe. And here we have an example. We have a circuit and we're showing a current, what you would see with a current probe if you connect it across these components. Notice we have R1, R2, and R3. R2 is open. So with R1, our current probe will sense a current in this component. R3, it senses a component. R2, it doesn't sense any current, and that would be our indication that this component is in fact open. Troubleshooting with a temperature probe. A temperature probe is another attachment that can be used with a digital multimeter, and that is with some digital multimeters. Not all will support them. Power dissipation in a circuit produces heat, and therefore relative values of temperature can be measured and used to troubleshoot a circuit. Temperature probes can be used to compare dissipation to other components, so you can use this to get a relative sense of power dissipation between other components on the same circuit board. Temperature probes can provide a general indication of current or no current based on heat. So you can use this to go in and it can just give you a general indication, is there current or is there no current flowing through a given circuit. Schematics don't usually address expected temperature, so you don't, on a schematic diagram, you don't typically have values that say you should have such and such a temperature on a component. Usually these schematics would indicate voltage, current, resistance, and such, but not typically temperature. Okay, effects of a short circuit. As in a series circuit, if a branch in a parallel circuit develops a short, extremely high currents may flow through the short circuit. The voltage across all branches of a parallel circuit will be 0 with a short circuit. The offending component will usually be damaged by the high current unless protected by a fuse or circuit breaker. So here we have a parallel circuit, and in this, from our parallel resistance studies, we would find that the resistance, the parallel resistance of these three would be 333 ohms. If we were to calculate the current in this circuit, if we did Ohm's law and we said E over R equals I, and we would get about 30 milliamps of current would be expected in this particular circuit. Now, if we had a short, okay, let's pretend that we had a short from here to here. Now notice that short is directly across the power supply. This is a little bit different than we saw in series circuits, and so this is going to put a tremendous load on this power supply. So where there was 333 ohms of resistance and about 30 milliamps of current being drawn from this supply, suddenly we're going to go down to a value. I mean, if we could say, let's just say that it shorts and it goes down to 0.1 ohms. Well, if that was the value, then suddenly our current is going to that's going to be required from this was going to jump up to 100 amps. Well, that simply isn't going to happen. Well, a couple of things might happen. For one, the power supply could just fail. For another, this component, likely the current through this component would be so severe that it would heat up and then it would simply open. Probably the most likely scenario is that you would have a fuse in this circuit, and when the current draw on this power supply became more than it could handle, the fuse would melt and the circuit would remain undamaged. However, when you put another fuse back in, you would just have the repeat fault, and then you would need to go in and begin to measure components and determine, well, what is the faulty component in this particular system. So that is an overview of symptoms you might see in a short circuit. Now, effects of an open circuit. An open in a parallel circuit will have less impact on the overall circuit operation. Voltages and currents across other components remain unchanged. Total current and power across the complete circuit goes down. Now, let's take a look at this. Now, if we have an open here, and we talked about this earlier in this particular lesson, but let's just talk about this a little bit. If we have an open here, notice this 10 volts, it is really not impacted by that, because it still provides 10 volts across R2, still 10 volts across R1, and we may not even notice that R1 is open. So when troubleshooting this, one of the things that we could consider, remember we looked at our parallel resistance, it would have been 333 ohms. If we had turned power off and we measured resistance across this, and this was in fact the case, our parallel resistance would be down to, or up to 500 ohms, because then it would be the parallel of just these two. So that would be an indicator that one of these components is in fact open. Commonly with a situation like this, when you have an open component, it is usually quite obvious if you just do a visual inspection, because usually the reason it's open is because it's overheated and it's open, and typically the component will be burned, or it might even be warm to touch if the circuit's been on. So those are some of the indicators that you might see in troubleshooting a circuit like this. Okay, so we've been looking at troubleshooting a parallel circuit. We looked at opens. We looked at the effects of a short, and remember that a short in a parallel circuit can be quite devastating. We looked at troubleshooting using a temperature probe as well as a current probe. And that concludes 5.2 troubleshooting parallel circuit.